Okay, and before we do this, well.
Do you have any space?
Yeah.
You just sent 10, and I don't have anybody in my honors leaving.
Yeah, that's fine.
Are you going to be in here all period,
or? We'll be in here most of the period, but that's fine. Just
okay.
Send them down. That's fine.
Okay.
No problem.
So we need some to go here. I can take half, and you can take half.
All right. So, okay, when we divide polynomials, when we divide polynomials, this is what's always going to happen. So let's say I've got two polynomials, f of x and d of x, just some random polynomials. If I divide those out, the answer is always going to look like this. I'm always going to get a polynomial part of my answer, and that's what this q of x stands for. It's just going to be a polynomial. And then I'm going to get this remainder. Okay, I'm going to get a remainder, which is going to look like, a fraction, like a rational function. I'm going to get a small polynomial, or maybe even just a constant, divided by whatever my original denominator was. That polynomial is going to be on the bottom of my remainder. Now this ought to look pretty familiar. This is the same kind of thing that you guys went through years ago when you did long division with numbers. For example, let's take a quick look at a long.
What is that?
I don't know. Why is this thing not? Huh. Back in the day. Okay, remember how we did this, right? Remember how we did long division? Well, okay, yeah, we want to see how many times the number outside. And by the way, if I were to write this as a fraction, which part goes on the top and which part goes on the bottom?
8 goes on top.
8 goes on the bottom.
8 goes on the bottom. Yeah.
Oh, I knew that.
Yeah, the denominator's outside, and then the number inside is going to be the numerator. Quentin. So we're going to see how many times 8 goes into 2. It doesn't, right? So then we got to scoot over one more place. How many times does 8 go into 20? 2 times. And then this process is going to be the same kind of pattern we're going to do with polynomials too. Once I get a number up here, what did I do? Okay, good. I multiply by what's out front. So 2 times 8 is 16. And then what do I do? I subtract. Aha. Okay, I'm going to subtract. And 20 minus 16 is 4. And then what do I do with the rest? Just write it down. Okay. 8 goes into 41. 5 times. And I distribute. And I get 40. And I subtract again.
1.
I bring down the 1. And the 03, right? Let's see. Does 8 go into 10?
Yes.
Once. Okay. 8 times. So I get 8. I subtract.
23.
And 2. 2 times 8 is 16. And then remember what you guys did. Did they have you, when you did this back in the day, did you put a little remainder box at the bottom?
Yeah.
Okay.
Back in the day.
Back in grade school?
Oh,
yeah.
Yeah.
I don't remember grade school.
Probably did. When you subtract 23 minus 16 gives us
Oh, no.
7. Okay, so the remainder is 7, right? Now, how do we write this answer then? A lot of times you were taught, and this was kind of a bad way to do it. We wouldn't do this anymore in grade school. But you were probably taught a lot of times to write your answer as 25, 12, R, 7. Do you remember doing something dorky like that?
Yeah.
Okay, that really doesn't make any sense to do. the way we really want to write this is 2,512, and what does that remainder mean?
0.7.
It means there's 7 left that didn't go into our denominator evenly. So we've got to have this fraction at the end, the 7/8. Right? Now that's a mixed number, so we could actually write that if we wanted to. We've got this integer part plus whatever fractional part we had left over from our remainder. We could write that as a mixed number, and we would know what we mean if we just did that, wouldn't we? 2,512 and 7/8. But and means plus. Really, it means plus. It means we're adding that additional fraction to the part that worked out nicely. Right? This is the part, this is how many times 8 divided evenly into our big number. But we had to have a little bit left over for our fraction. Okay, that's the same thing we're going to see with polynomials. If I scoot back just a little bit here, right? So we're going to get the same kind of thing. We're going to get, there's what I want to be. We're going to get the same kind of answer. We're going to get a nice, oh jeez, we're going to get a nice polynomial part of our answer, and then we're going to get some remainder. Okay, and let's see it in action. So here's how we do this. If I want to divide this big 4th degree polynomial by this 2nd degree polynomial. Now, which part goes out front? The bottom part. Okay. So we'd write it like that. Okay. Now, here's how we play this game. What we want to do is we want to always look at the leading terms. So we want to look at the leading term outside, right there, and the leading term inside, and we want to ask ourselves, how many times does the leading term outside divide into the leading term inside? In other words, what is 2x to the 4th divided by x squared? Okay. Okay, well, 2x to the 4th divided by x squared, 2 over 1 is 2, and x to the 4th divided by x squared is just x squared, right? Okay, so that's how many times the leading term outside divides into the leading term inside. And so we're just going to put that up on top of the polynomial. Now, they like to put it over the column for the x squared. You don't really have to. That's fine. I mean, I usually just put it right up here. But you can do it this way if you want to. Now, I want you to notice one other thing. In our original polynomial, notice that we didn't have an x squared term. It only had 4 terms. It was, the numerator was 2x to the 4th plus 3x cubed plus 5x minus 1. But look what we did. We kept a column for the x squareds. Right? Now, you're used to doing that. We've done a lot of stuff like that already in Chapter 6 when we multiplied polynomials vertically. Remember we did that kind of thing? When you divide, it's absolutely essential. You have to keep a column for each power of x, or it just won't work. And you got to always put those 0 coefficients in there if they're missing, if you get a missing term. Okay, so now what? What did we do with our long division problem when we got a number up top always?
Times it.
Yeah, we just multiplied by whatever's out front. Same concept here, only this time multiplying it is a little bit harder because we're multiplying polynomials. We have to distribute this term to all 3 parts of our polynomial out front. Okay? So 2x squared times 2x is going to be 4x squared, and that's going to line up in the 4x squared column, right? 2x squared times negative 2x is what? Negative 4x cubed. Right? X squared times x to the 1 would be x cubed. So that's going to go in the x cubed column. Okay? And then finally, 2x squared times x squared is 2x to the 4th. And that's not a surprise because we picked it so it would do that. We want the big terms to cancel when we subtract. That's why we picked this number. So the big ones are always going to go away when we do long division. Right? Now, here's another really important thing. When you're writing this down on paper, and you need to do that, there's no way you can try to do this in your head, or just you got to write this down or you're going to make tons of mistakes. This is an important step. We're going to subtract this from this polynomial right here from the big one on top. And so what you got to do is you got to put it in parentheses and put a negative sign out front. So that reminds you that you're always going top term minus bottom term. Okay? So over here we've got 0x squared minus 4x squared is what? Yeah, negative 4x squared, right? Here we got 3x cubed minus negative 4x cubed is 7x cubed. Good, because subtracting a negative is adding. So we're going to get 7x cubed there. And then finally, 2x to the fourth minus 2x to the fourth. Those cancel, right? And then what do we do with the other ones, you suppose? Bring them down. Absolutely. And now look what we got. Now we got a smaller polynomial to work with for the next step. Yes, sir?
Oh, no wait, never mind, I was gonna ask, that's a negative 4x cubed, but now
Makes sense, because we're subtracting. Okay, in long division, we subtract, just like you did with numbers. Okay, so now what do you suppose you do? Divide again. Yeah, we go leading term outside, divide into leading term inside. So there's two ways to think about this. You can say to yourself, what is 7x cubed divided by x squared? You can get the answer that way. The way I tend to do it, actually, I always just ask myself, x squared times what is 7x cubed? To me, that's just easier to think of. But either way, it doesn't matter. Either way, the answer is 7x, isn't it? Right? If I divide them out, 7 over 1 is 7, x cubed over x squared is x to the 1. And so 7x is the next number that appears in my polynomial on top. Now what?
Times.
Yeah, distribute that through what's out front. Okay, and we just do the same process over. We'll subtract. So 7x times 2 is 14x. That lines up in the x column. 7x times negative 2x is negative 14x squared. It lines up in the x squared column. 7x times x squared is 7x cubed. And then I'm going to subtract the whole thing. Right? So when I look vertically, the x cubed terms cancel. Now, make sure this is where people make mistakes on this. People sometimes do things like negative 4x squared minus 14x squared. A real popular thing would be to say negative 18x squared. But remember, you're subtracting a negative in this case. You're subtracting the negative 14x squared, which is added. So we see how we get the positive 10. 5x minus 14x is negative 9x. Okay? Next, what do I do? Okay, but first you got to bring that negative 1 down. Okay? And now I divide again. This is an easy one. X squared times what is 10x squared? What do I have to multiply x squared by to get 10x squared? 10, sure. Right? Okay, so if I distribute the 10 all the way through, 10 times x squared is 10x squared for the x squareds. 10 times negative 2x is negative 20x, x column. 10 times 2 is 20 for the constant column. Subtract, and that's what we get. 11x minus 21, right? Okay, now, does x squared divide into 11x? No, doesn't. It's not going to divide in there. And so this is my remainder. Okay, another clue that we were done on the last step is that we got a number 10 with no x's, right? So that last step through, x squared went into 10x squared exactly 10 times. Notice that in my answer up here, the polynomial, the powers of x have just decreased, and once we get to the constant, we know that we're done with the polynomial part, and now it's just a remainder. Now it's possible there won't be a remainder, but in this case there is. Okay, we get the remainder, 11x minus 21, so we put a remainder box around that. And now, how do you suppose we write our answer? How do we write our answer? Okay, we get this number. There's the polynomial part of our answer. So yeah, so this part isn't. This part is going to be the regular. This is like, remember in our long division example, this is like the number part, the 2,512, right? Okay, so that part. Yeah, there you go. Good. So our answer is going to equal that 2x squared plus 7x plus 10, but this part down here is our remainder, right? So that's got to go in the numerator of the leftover part. So plus 11x minus 21 over what?
X squared minus 2x.
Exactly, the original, this is our denominator, isn't it? Oops. Right? So that goes on the bottom. X squared minus 2x plus 2. So that whole thing is our answer. Okay? So there it is. Okay, quotient, so we get this nice quotient polynomial plus remainder over the original denominator. Okay, that's the process. We'll do another one of these later. I'm not going to do another one of these today, but I want to show you today as a trick. Now, this is one, unfortunately, where we would have to do long division because, and here's the reason, because the denominator has a degree of 2 or higher. But if the denominator is linear, if the biggest power of x in the denominator, or y, or whatever the variable is 1, there's a great shortcut. And you already know it. That's the good news. So I'm going to skip ahead here. Okay, let's try this one. And we'll come back and talk more about this stuff later. But for now, I just want you to get used to this process. Okay. You know what? I'm just going to do this. Like the way this is set. We'll just do this example right here. So. Okay, so if I want to divide, and really what I'm doing then, I've got the fraction 3x cubed minus 2x squared plus 2x minus 5 divided by x minus 2. Okay, that's the polynomial division problem that we're doing. Because the bottom is linear, because the power of x is 1, I can use synthetic division, which is the same as that synthetic substitution trick I showed you earlier. So all we have to do with this process is set up a synthetic bracket, and we're going to put the coefficients, so the 3, the negative 2, the positive 2, and the negative 5, those are going to go into the top of our synthetic bracket, just like they did for substitution. So the 3 goes first, then the negative 2, then the positive 2, then the negative 5. Okay? Now what's the number that goes out front? All you have to do for the number out front is we're going to take the denominator and find it 0. So if I set it equal to 0 and solve, I get positive 2. Okay? So that's the number that goes out front. And it's the same process as before. Okay, so how did I do that process for substitution? Drop the 3 down. Oh, and by the way, I didn't have to put in any 0 coefficients here because I didn't have any missing terms. But remember, if I had had a missing term, I would have had to put a 0 in there too. Okay? So I dropped the first guy down. Now what? 2 times 3 is? Do I add or subtract? You add. You do the opposite of long division. You add with synthetic. So negative 2 plus 6 is 4. 2 times 4 is 8. 10. 2 times 10. 15. Okay, so now how do we interpret that? How do we interpret that? So here's how we interpret that. This part right here, this 3, 4, and 10, those are the coefficients of the polynomial part of our answer. Okay. They're going to go in regular order, so they're going to go from, this is going to be the weakest power, and that's the strongest power. The way to do this is to, you always know that the number next to the remainder box is the constant. That doesn't get a power of x. What's going to be the power of x with the 4? No, it's gonna be just x to the 1. We're just gonna step up. We go constant, x to the 1, x squared. I could keep going, x cubed, x to the 4th. But this one's gonna stop at x squared. Okay? So we drop those down and those become the coefficients. So this looks like 10. This one becomes positive 4x. And this one becomes positive 3x squared. Okay, so those are the coefficients in order. And then what do you suppose this is? That's the remainder. So we're going to get plus 15 divided by x minus 2. Quick and easy compared to the long division one, isn't it?
So that's only if x is like by itself, it's not.
Right, that's only if the power of x is 1 on the bottom. If it were x squared or x cubed or something, you'd have to do the other way. Polynomial long division. Okay? Make sense? Okay, let's see if we can't. That's all I want to do for today. I don't want to load you down too much.
Well, you can do that.